Welcome, viewers. Today, we will be looking at how to derive the quadratic formula, which we can see x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we will be deriving this quadratic formula using the completing of squares. We will be deriving the quadratic formula as seen above using the completing the squares method. Before we proceed, it will be appreciated if you can kindly subscribe to this channel and also hit the notification bell so that you are promptly notified of videos that are uploaded on this channel. So looking at the expression above, which is the general form of the quadratic equation expressed as ax squared plus bx plus c is equals to 0. That is, a not equals to 0. What this simply means is that a must not be 0. And assuming a is even 0, what happens to that expression? You'll see that that first term, which is ax squared, is knocked out because it now becomes 0. And once that first term is knocked out, we are left with bx plus c is equals to 0. And it now becomes a linear expression. I want us to know that a can be less than 0, that is negative, and of course a can be greater than 0, that is positive. But a must not be equals to 0. Now let's divide through the quadratic expression ax squared plus bx plus c is equals to 0. Let's divide it through by a so that we can have the coefficient of x squared to be equals to 1. Once we do that, we divide the left-hand side by a and the right-hand side by a, that is dividing all through by a. We are left with x squared plus b over ax plus c over a is equals to 0. Now, we will be taking the c over a to the right-hand side. So currently it is a positive value. The moment it moves to cross over the equality sign, it changes from a positive value now to a negative value, as we'll be seeing in the expression below. So what we have is x squared plus bx all over a and is equals to minus c over a, as we had anticipated. Now, we'll be doing something. What we will do is to introduce some form of expression. You'll notice that we introduced this value on the left-hand side, and we also introduced that same value on the right-hand side. Now, what we simply did was to divide the coefficient of x by 2. And what is the coefficient of x? The coefficient of x is b over a. And when we divided it by 2, we have b over 2a. So dividing it by 2, number 1, and then squaring it is what we have done to both the left-hand side and to the right-hand side. That is, we added that value to the left-hand side and also to the right-hand side. Now, what this does is to now make the expression x squared plus b over ax plus b over 2a all squared to become a perfect square. And that's the reason why we introduced the b over 2a all squared. And what we did is to add it to both sides. But in adding it to both sides, we have made the left-hand side to be a perfect square. So what we have now is, as you can see above, is x plus b over 2a all squared. X plus b over 2a all squared is what we have on the left-hand side. And what we have on the right-hand side, by the time we expand, we have b squared over 4a squared minus c over a. So let's look at the simplification. We have arrived at x plus b over 2a all squared, and that is equals to b squared all over 4a squared minus c over a. We have arrived at x plus b all over 2a all squared, that's on the left-hand side, and is equals to what we have on the right-hand side, which is b squared all over 4a squared minus c over a. Now, if you look at the right-hand side, we will be trying to have an expression that has the same denominator. We have 4a squared here, and then we have a. Now, for us to have the same common denominator, we can multiply the c over a with a 4a at the bottom and then a 4a at the top. So by the time we have 4a at the bottom multiplying a, we now have 4a squared. So let's see how this goes. So the whole objective is to have a common denominator, and that's what we have as expressed. So we now have x plus b over 2a all squared is equals to b squared over 4a squared minus 4a times c and also 4a times a. Remember, the whole objective is to have the same common denominator. Now let's simplify this further. We have x plus b over 2a all squared is equals to b squared over 4a squared minus 4ac all over 4a squared. So we have succeeded in having the same denominator. It therefore means we can combine the expression into one. And when we do that, we have x plus b over 2 all squared is now equals to b squared minus 4ac all over the common denominator, which is 4a squared. We have equals to b squared minus 4ac all over 4a squared. Now remember, the whole plan is to solve for x. The whole plan is to solve for x. But we have the x in this expression. It is being squared. That is x plus b over 2a all squared. And that gives us what we have on the right-hand side, which is b squared minus 4ac all over 4a squared. So for us to be able to solve for x, the first thing is to find the square root of that expression. So we will be finding the square root of both sides, and that gives us what we'll be seeing, x plus b over 2a all squared is equals to b squared minus 4ac over 4a squared. Like we said, we will find the square root of both sides, and that gives us this expression. By the time we find out, or by the time we get the square root of the left-hand side, we are left with x plus b over 2a. And of course, the square root of the right-hand side is the same as the square root of the denominator divided by the square root of the numerator. I beg your pardon, the square root of the numerator divided by the square root of the denominator. That is square root of b squared minus 4ac divided by the square root of 4a squared. Now, if we do that, we have x plus b over 2a, and then we now have is equals to plus or minus the square root of b squared minus 4ac divided by 2a. You notice that the square root of 4a squared is equals to 2a. So we have x plus b over 2a, and that is equals to plus or minus square root of b squared minus 4ac, all divided by 2a. So what we have done is to arrive at the expression x plus b over 2a, and is equals to plus or minus square root of b squared minus 4ac all over 2a. We will be solving for x, so we will retain x on the left-hand side, and therefore we will be taking this expression plus b over 2a to the right-hand side, so that we have x alone on the left-hand side. And when we do that, the plus b over 2a, when it crosses the equality sign moving to the right-hand side, it will now become minus b over 2a. And let's see how that plays out, just as we had anticipated. So what we have now is x on the left-hand side as the subject of formula, and is equals to minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. Now we can clearly see that there is a common denominator, 2a here in that expression, and also 2a here in this expression. It therefore means that these two expressions, minus b over 2a, and this other expression, plus or minus b square root of b squared minus 4ac all over 2a, can be combined into one expression, as we'll be seeing below. So since they have a common denominator, they can be combined as x being equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So we have been able to successfully derive the quadratic formula x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. We will be applying this right now, as you will see. So let's look at this example. It's a quadratic equation. X squared minus 6x plus 8 is equals to 0. Now we know the general form of a quadratic equation as ax squared plus bx plus c is equals to 0. Now from here we can determine what our a is, our b, and our c. A is simply the coefficient of x squared. That is, what is the constant term, or what is the term multiplying x squared. And here we can clearly see that our x squared is being multiplied by 1, and therefore a is equals to 1. Now, what is our b term? Our b term is the coefficient of x. That is, what is multiplying x, and that is b. And that is minus 6. And then our constant term clearly is 8. So what we will simply do is to apply the quadratic formula which we have derived, and then simply input the relevant constants into this formula. So we have minus b, which is now minus 6, plus or minus square root of b squared. B is minus 6, so it's minus 6 squared minus 4ac. A is 1 and c is 8, all over 2a. That is all over 2 times 1. And then we will simplify it further. We have 6 plus or minus square root of 36 minus 32 all over 2a. Note that the minus 6 now becomes positive 6, and that's why you have 6 plus or minus square root of 36 minus 32 all over 2a. Now, when we simplify this further, we have 6 plus or minus square root of 4 all over 2. So that means we have x is equals to 6 plus or minus 2 all over 2, which tells us we have two possible answers, 6 plus 2 over 2, or x is 6 minus 2 over 2. So if x is 6 plus 2 over 2, we have x to be 8 over 2. Therefore, x will be 4, because 8 divided by 2 is 4. And then if x is 6 minus 2 over 2, we are saying that x is equals to 4 over 2, because 6 minus 2 is 4. So you have 4 divided by 2, and therefore x will be 2, because 4 divided by 2 is 2. So this is the answer to solve the quadratic equation using the example above. Kindly subscribe to this YouTube channel, as more and more valuable content will be brought to you regularly. Thank you.